Alright, welcome back. In this video, I'm going to do some examples of working with linear equations and how they relate to different applications. Before you get to the examples, we kind of need to look at a couple of the formulas that are very typical of seeing with linear equations, especially when dealing with one variable. And some of those equations are as follows. We've got the distance formula. So d equals RT. So d is the distance, r is the rate. This is going to be in speed. So we're talking about things like miles per hour, kilometers per hour. You definitely know that you're using a distance formula if your word problem is talking about how fast something is traveling. Then we have simple interest, so I equals PRT. I is your interest, P is your principal, R is your rate, T is your time. And in this case, your rate is going to be a percentage. So we're talking about things like 2.3%, and we would translate that into a decimal form, okay? We also have what's called compounding interest. So compounding interest is something a little bit more similar to what banks do. What this means is that you are receiving interest into an account over different periods of time throughout the course of a year. So in this case, our time is definitely going to be in terms of years. And we're talking about how many times you would be having that interest deposited into an account over the course of however many years you're talking. Okay, so with compounding interest, that's what we're looking at. And then the other two more famous is area and perimeter. So of course, length and width is L and W. And then perimeter being that addition. So I like to think of perimeter as you're going to take a walk around the shape and you need to add up the sides as you go. And perimeter is talking about your exterior walls, whereas area would be talking about what it might take to blanket your room. Or if you're thinking about a house, an area would be how much, say, carpet is needed to fill the space. And so therefore, that's why we do the multiplication. Okay, so we need to keep these different formulas in mind as we attack some of these problems. Okay, so let's go ahead and take a look at your first one. So here we're given an example. And in this example, we are told that you need to be able to write your equation that you need to use to solve a problem. So whenever you're doing application problems, the best thing to make sure you always do is to start out with a picture. So I have two trains, and these two trains are 630 miles apart, and they are heading directly towards each other. So I can draw that picture very simply. I have two trains, so we're going to start with our first train. So this is train A. And what I know about train A is that he is traveling in this direction. Okay. And then I have a train B. So here's my train B, and he is traveling in this direction. And I know that because they're traveling towards each other. And I also know how far apart they are. So if I'm looking at my total distance here, I am told that this is 630 miles. Okay. Now the second sentence is going to give you more information about your trains. So I have that the first train is traveling at 95 miles per hour. So I would go ahead and label that my train A is going 95 miles per hour, and then my second train is traveling at 85. So I would go ahead to state then that my train B is the 85 miles per hour. So those are going to be your rates. Those are how fast your different trains are going. And the question wants to know how long before the trains pass each other. So we're looking at how long is it going to take in order for them to essentially line up at the exact same spot before carrying on their ways. So here I have a distance, 630 miles, and I have rates. I have the rate for my first train, so its speed is 95 miles per hour, and I have a rate for the second train, so its speed is 85 miles per hour. So this means that I have to use D equals RT as my equation that I have to start and work with. So to do that, I have to be able to fill some information in. So first thing that I need to know is I have two trains that are traveling towards each other. So when you have trains traveling towards each other, what that means is that your rates have to be added together. Your speed is coming together, and so therefore we have to add them together. So that is going to change my equation a little bit. So my distance is going to be a different type of rate, and here I'm going to add them together. And so what I'm doing here is I'm taking the rate from my first train, and I have to add that to the rate of my second train. Now I'm trying to find time altogether, and so I just simply now have to plug my information in. So what do I know about my distance? Well, I know my distance is 630 miles. So I have 630 is equal to, I know the rate from my first train is 95. So this is going to be 95. And I have to add that to the rate of my second train, which is 85. And then time is the one thing that I don't know. That's what I'm trying to discover. So simply all I have to do here is I just have to solve for t. So the first thing I need to do is I have to take my 85 and 95 and I need to add them together. So I have that 630 is equal to 180 t. And then I need to divide both sides by that 180 to get t. So in this case, I'm going to have that my t is equal to 3.5, and in this case we are talking about hours. Now most of the times you'll hear a lot of your instructors state that you cannot have decimals unless you're asked for them. And that's a very important concept. It's because you want to make sure that your answers are always given in exact terms. However, when we're talking about time, time is going to be your exception. Time is usually given as a decimal term. If you think about a stopwatch, time counts up in decimals. It does not count up in fractions. And so therefore, when you are giving answers as it relates to time, in general, it is okay to use its decimal form. So we would say 3.5 hours. However, I don't know of a single instructor who would count you off if you had written 3.5 hours. So it is kind of your choice what you want to use. I particularly prefer the decimal when dealing with time just because it's easy to stay well-rounded. But there you have it. That is an example of a distance problem. Okay. So let's look at another one. So here I have that two brothers, Rick and Tom, each inherit $10,000. So right away I can already say that this is going to be some form of a finance problem. And what I have to determine or decide is this finance problem dealing with simple interest or dealing with compounding accounts? And the way you determine that is based on what you read. Okay, so we have to look at what pieces of variables do I actually have. So I know that they're going to inherit $10,000. It says Rick invests his inheritance into a savings account with an annual return of 2.25%, while Tom invests his in a CD paying 6.15% annually. The question wants to know how much more money does Tom have than Rick after 1 year. So I have to set these up. So the first thing that I have is I have Rick. And I need to look at what Rick has. So I know that he inherits $10,000. So his P, or principal, is that $10,000. I also know that his rate is going to be 2.25%, which I have to change to a decimal. So remember, if you're in percent form, to get decimal form, you have to divide by 100. So here, my decimal form is going to be 0.0225. And then I'm also told that I'm looking at 1 year, okay, i.e. annually. So that is Rick. Well, the other thing I have to look at is I need to look at Tom. And in terms of Tom, I'm told that I have a principal, again, of $10,000. I am told that I have a rate of 6.15%. Again, change that to a decimal. I have to divide by 100. So this is 0.0615. And I'm also told annually, which is 1 year. So the easiest way to figure out who has more money after a year is going to be to use simple interest. So I want to use your simple interest formula, which says I equals PRT, where P is your principal, R is your rate, and T is your time. So I need to calculate the simple interest for both Rick and Tom and see what I've got. So my interest for Rick is going to be calculated as my principal, so $10,000, times my rate, 0.0225, times my time, 1 year. Okay? And so that is going to give me my interest for Rick. So when I do that, obviously 10,000 times 0.0225 times 1 is going to give me a total of $225. And I can leave it there. Now you could go ahead and calculate how much was in the account, but since they're both starting out with the same amount in the account, you can stop at interest. Well, at the same time, you need to calculate the interest for Tom. So again, this is going to be my $10,000 times his interest of 0.615 times 1 year. So 10,000 times 0.615 is going to give us $615. The question wants to know how much more money that Tom has than Rick. So in order to do that, says in order to find the money or amount more, says I have to take the interest for Tom and subtract out the interest for Rick. So in doing that, I have the following. My interest for Tom was $615. I'm going to subtract away the interest for Rick, which was $225, and that is going to give me an overall result. So in this case, what you're going to find out is that you have 390. Well, 390 does not just simply answer the question. Instead, what is that 390? Well, we now know that Tom has 390 more than Rick. Okay. So that is a quick look at a simple interest problem. So let's look at another. So here we have twice a number decreased by 9 times the number is equal to 5 times the difference of a number and 4. And the question wants you to find the number. So to do this one, you have to do what's called unpack or translate your English sentence. And you need to translate it into a mathematical statement. To do that, says you need to start with the very beginning of your sentence and read it very slowly. First of all, I have twice a number. So twice is another way for saying 2 times. So I have a 2. And then a number is easily represented by a variable. Now you've got 26 letters in the alphabet, so unless you are told, feel free to be creative. However, most students choose X, so I'll go ahead and use that. So we have twice a number. Decreased means subtraction, so we have to subtract. And then I have 9 times the number. So again, 9 times is going to be multiplying, so I have a 9. And then in this case, the number is actually referring to the beginning of my sentence, where I had a number to start with. So since I labeled it as an X, I have to do that again. Now is equal to means your equal sign. And then I have 5 times the difference of. Okay, so I want to point out times the difference of means parentheses. So this right here is talking about a parenthesis. And then the difference is talking about the sign inside the parentheses. So here we are talking about a subtraction. So 5 times means my 5 is on the outside. I then have to input my parentheses, and I'm going to input my subtraction. Now I have to figure out what my subtraction is. And it's right here, the number and 4. So again, the number is referring to what we had in the beginning of our sentence. So the number is going to be X, and then 4 is just simply 4. Now if you notice, I have a period. So the period signifies the end of that specific equation. And the reason I point that out is because sometimes you will be given these problems where you have multiple sentences. Each sentence represents one equation. So as soon as you hit that period, that means if anything else comes next, you're opening up into a second equation. So here I have to find the number. So I just simply have to solve the linear. So 2x minus 9x is going to give you a negative 7x. I then have to take this 5 and I need to distribute it through my parentheses here. So this becomes 5x minus 20. And then here there's a couple things you can do. You can either just simply move the 5x over, but then you need to remember you have this negative to deal with. Or you can do what I like to do, which is I like to keep my things positive. So I would take this 7x and I would move it to the other side, making my variable a positive number. Since it is a negative, means to move it says I have to add across my equal sign. And that then means I would take this 20 here and I have to move it to the other side. Since it is being subtracted, to move it also says that I have to add across the equal sign. So my equation is going to become 20 is equal to 5x plus 7x. Simplify. I have 20 is equal to my 12x. Divide everything by 12. I have 20 over 12 is equal to x. And remember, you need to reduce. So 20 over 12, what's in common between these two is a 4. So I'm going to divide a 4 out of the top and bottom. So 20 divided by 4 gives me 5. 12 divided by 4 gives me a 3. Thus, my number was 5/3. Okay. Now here I have find 3 consecutive odd numbers such that 7 times the second number decreased by twice the first is 6 times the third. So there's a few things that I need to recognize here, and those are I have 3 numbers that I have to find. So I have my first number, my second number, and my third number. And before I even get started, I have to be able to put variables to those numbers. So my first number I might call n. Now I'm looking at consecutive, I apologize here. I actually want these to be even. My mistake. So let's look at even numbers. So if I start at any even number, in order to jump to the next even number means I have to jump over the odd. So here, this is going to be where I started, and I have to add 2 to it. To get to my third means I have to jump again, so I would go from where I started, and this time I have to add 4. And you would do that over and over and over, depending on how many numbers you have. Now, I have to translate my English sentence. So my English sentence starts right here. Okay, so this is where I'm going to start. And I have to translate from this part forward. So I have 7 times the second number. So I'm going to go ahead and do 7 times my second number, and then I have to do decreased by, so that means subtraction, twice the first, so twice times my first number, is means equals 6 times the third, 6 times my third. So what I did here is I just wrote the very basic steps. So I need to input what I know. And what I know is that my second number here was n plus 2. My first number was n. And my third number was n plus 4. And I got those based on the designations I did in the beginning. So I need to rewrite my equation. This is 7 times n plus 2 minus 2n is equal to 6 times n plus 4. Solve for n. So I'm going to take the 7 and I'm going to distribute. And then I need to take the 6 and I need to distribute. 7 times n gives you a 14n. Sorry about that, gives you a 7n. 7 times 2 gives you 14 minus my 2n. 6 times n is a 6n. 6 times 4 is 24. I need to combine my terms, so I'm going to look at combining my 7n and my 2n first. So 7 minus 2 gives you a 5n plus 14 equals my 6n minus or plus 24. I am then going to take my 5n and I'm going to move it to the other side. Because it's positive, that means it's adding. To move it across the equal sign says that I have to subtract. I'm then going to take my 24 and I'm going to move it across my equal sign. Since I'm adding, in order to move it again, says I have to subtract. So I'm going to have 14 minus 24 is equal to 6n minus 5n. Complete my subtraction, and I have negative 10 is equal to n. So what I just found is that this right here is my first number. Well, I need to find the other 3. So you do that very simply by coming back up here to what we know. And we know that my first number is equal to a -10. So n is -10. To find my second number says I have to take my first, -10, and I have to add 2 to it. -10 plus 2 is a -8. And then for my third number, I have to take where I started from, -10, and I have to add 4 to it. So -10 plus 4 is a -6. So therefore, my answers are going to be that my solution is -10, -8, and -6. And those would be my 3 consecutive even numbers that satisfy the equation given. Okay? So I hope you enjoyed this mini lesson on applications. If you have any questions, please let me know in the comments. Otherwise, I will see you next time.